Um, Welcome back and good morning. Thanks, Ray, for the introduction. As a quick reminder, please, if you haven't done so already, find the roll call link in the chat and please sign in using the link that Karen will be providing. My name is Scott Bass. I am a water resources engineer, as Ray described, and I'm with the MD Dam Safety Inspections and Compliance Division. Today, my topic of discussion is hazard classification and hazard creep. So we're talking about, we have a group of presentations called What's in Your Pond? So what is in your pond? And a dam, probably. As most of you probably know, there are no natural lakes, and maybe with the exception on the Eastern Shore, very few natural ponds. So at the heart of every pond in the state of Maryland is a dam. But my presentation today is on what's downstream of your pond. So first, a little bit of definitions. What is a dam? Well, in Comar, dam means any obstruction, wall, or embankment together with its abutments and appurtenant works, if any, in, along, or across any stream, heretofore or hereafter constructed for the purpose of storing or diverting water or for creating a pool upstream of the dam as determined by the administration. So as you can see, that's a pretty broad definition for dam. And at the Dam Safety Division, we have 3 classifications for dams. The first being low hazard, which means, and again, these hazard classifications are based on the consequences of failure and not on the condition of the dam. The first is low hazard, meaning no loss of life, little to no economic impact, and impact to low volume rural routes only could be expected if the dam were to breach catastrophically. I will note that we are talking about what's in your pond today, so all of these small ponds that we're dealing with will be this low hazard classification. They cannot, a small pond by definition cannot be significant or high hazard. And so the significant hazard dams means that 1 to 6 lives could potentially be in jeopardy. And this is a concept known as population at risk that we'll get into later. You could expect economic impacts, roadway impacts to main thoroughfares. High hazard means loss of life is likely. This is different than population at risk, which we'll get into later. And both of these 2 higher classifications require an emergency action plan. So another definition from Comar, and this is the permit requirement. So a person who proposes to construct, reconstruct, repair, or alter a dam, reservoir, or waterway obstruction or change in any manner the course, current, or cross-section of a stream or body of water within the state except tidal waters, including any changes to the 100-year frequency floodplain of free-flowing streams, shall obtain a permit from the administration before commencing work. So we have a broad definition for dams, and we have a requirement that any modification to those dams or construction of one or removal shall obtain a permit from the department. There will be a link in the chat shortly for the joint permit application. This is the application that needs to be filled out if you or somebody in your jurisdiction plans to make a modification to a pond or construct one. And basically when these come in, we have 2 options if it is in fact a pond or dam, and that is to issue an exemption from this permit requirement, from dam safety permit requirement, or we have to issue a permit. With the What's in Your Pond group, we're mostly going to be talking about this exemption requirement where a local jurisdiction can review and approve the pond. And I will say all permit applications must include a dam breach analysis or assessment and discussion of the appropriateness of one that was conducted previously. So let's talk about this permit exemption. What this allows for is if it's small enough and it meets certain criteria, it can be approved by the local SCD or the department's designee. So there are 4 requirements that have to be met for us to be able to exempt a dam to one of these jurisdictions. And 3 of them are very simple. The first is the drainage area to it has to be less than a square mile. The height has to be less than 20 feet. as measured from the upstream toe to the top of dam. The storage volume must be less than 50 acre-feet. And finally, there's this low hazard classification, which isn't as simple and requires an analysis, which I'm going to talk about today. Just a quick note, an exemption from a dam safety waterway construction permit does not relieve the applicant from obtaining any other necessary state, federal, or local permits. So let's talk about, if you will, the Bible of small ponds in Maryland, and this is Maryland Pond Code 378, the law. Don't worry about all this text. I'm going to highlight what's necessary for you. In Pond Code 378, there is a section on structured hazard classification. Right in that section, it says, documentation of the classification of dams is required. And furthermore, it says the classification of a dam is the responsibility of the designer and subject to review and concurrence of the approving authorities. So as much as we'd like to be able to give a yes or no, a thumbs up or thumbs down, like Caesar on these ponds, it really isn't our place to be doing this analysis, though we have good gut feeling on whether or not it should be low hazard or not. This is the responsibility of the engineer, and it shall be provided, no questions asked. Again, this is only the pond code that's acceptable if the failure of the dam will not result in loss of life and damage to homes, commercial or industrial buildings, main highways or railroads, or interruption of the use of or service of public utilities. And finally, Pond Code 378 goes into how this should be determined, and it has a fairly conservative criteria for determining what the resultant flow would be if a small pond were to breach, and that only considers the height of the dam, which is a problem that I'll touch on a little bit later. So continued, Pond Code 378 allows these ponds to be approved if the depth of flow over a road is less than 1.5 feet. And it also defines Class A, Class B, and Class C structures similar to the low, significant, high hazard classifications that I touched on earlier. So let's talk about this concept called hazard creep. And a lot of times we'll get an applicant that resists this requirement that's spelled out in Pond Code 378 to provide a dam breach study because, well, this pond was approved and built in the 70s, so clearly they determined that it was low hazard then. Why do we need to provide that determination again? Well, there's this concept of hazard creep in addition to modeling changing since the 70s with the advent of computers and all that. But here's a clear example. This is a Google Maps screenshot. This was an agricultural pond that was built on a strawberry plantation. This was for irrigation. So as you can see, this is clearly not a pond that exists on a farm now. That pond has long since, or that farm has long since been sold and now is a suburban development. And to the left of this picture, you can see there's embankment right up against these homes. So clearly, failure of the dam in that location could present a threat to the occupants of that home. And thus, this is what is known as hazard creep. The hazard was low hazard. Downstream development has changed that hazard. Here's another example from Kaiser, West Virginia. The pond is in the upper left corner of that. You can see the downstream area. What was open space is now highly developed. Failure of this dam clearly presents a hazard to roads and houses. So one lesson of this is to use the ultimate development when conducting a dam breach analysis, and that should prevent you from having to go back and upgrade the pond at significant cost later on. Another one is dam longevity. So this dam's never overtopped in 100 years, so clearly these studies are wrong. A, this is wrong, design standards have changed, and B, they may never have seen the storm event that was contemplated when they were built. Here's an example on the Eastern Shore, a state highway road that had overtopped. We had identified it as having an undersized culvert which the engineer and administration kind of resisted because it had never overtopped. And sure enough, it overtopped soon after then, and the road was closed for months. Here's another one. If you were following Maryland dam safety news in 2018, an old mill pond or a mill dam in Carroll County with hand-placed stones in the downstream face of the dam, over 100 years old, overtopped and nearly failed catastrophically during a summer storm event. Anyway, I think that illustrates the point. And dam purpose.
About 10 minutes left. About
Oh,
10
really?
minutes left.
Okay. Dam purpose. This doesn't need a study because it's primarily a transportation structure. Here's an example from the NTSB, National Transportation Safety Board, where with an undersized culvert that was acting as a dam. Some upstream beaver dams actually breached, overwhelmed the culvert, and actually a few lives perished whenever this train derailed. Some of you all might be familiar with, okay, the local jurisdiction, it's close to being a hazardous structure. This gets kicked to the Dam Safety Division for further analysis. And some past guidance that you might be familiar with, and a guy you might be have known, Bruce Harrington, had a few guidance documents. The first was for small ponds and dams, and the second was for full-blown dams, and where the distinction between those were a 15-foot in height. If you were above 15 feet in height, you had to do a danger reach study for dams, and if you were less than that, it was for the small ponds and dams on the left. I will note that the 15 feet in height is less than what we can exempt up to 20 feet. And the small pond and dam said simple brim up analysis may be necessary. So what does that mean, may be necessary? We've since that time tried to clarify some of the gaps that were in these guidance documents. And that brings me to the May 2018 guidance, which is on our website, and Karen has helpfully linked to in the chat. I encourage you to read this guidance document. So like I said, we try to fill in the gaps or the confusion that may have been provided in past guidance. And I want to highlight basically the core principles of this, and that is determining a hazard due to dam breach. And the factors, this is right from the guidance, the factors that must be considered in order to determine the hazard classification of a dam include but are not limited to the population at risk, depth and velocity against buildings, roads, and where unprotected persons could be expected, let's say park areas, isolation of populations from emergency services, think sole access roadways where people would be stranded from emergency services, damage to critical infrastructure, and less frequently economic loss and environmental damage, though we reserve the right to make those considerations. So there's this new, not a new concept, but we clarify this concept of population at risk in the document. And what is population at risk? This is commonly simplified to PAR. It includes those persons present in the inundation flood zone at time of failure, including permanent residents and transient individuals such as recreationists or the traveling public who, if they took no action to evacuate, may experience an increased hazardous flooding condition due to dam breach based on depth and velocity of the flood wave. Seems pretty straightforward to me, but I'll have to clarify a little bit. And just a note, this comes from the USBR ACER Technical Memorandum number 11, which is available on our website. I encourage you all to read this. And how we define this are these helpful charts, which have depth on the y-axis and velocity on the x-axis. We have this for various critical locations, which I'll talk about later. And I quickly want to make a distinction between population at risk and loss of life. So the department may assign a higher classification based on loss of life rather than PAR. Evaluation of loss of life from a dam failure requires a lot of judgment, assumptions, etc. So what does this mean? Based on those charts I just showed, we could determine that cars, residents in homes, people in parks are at risk due to dangerous levels of flooding as defined by a depth and velocity. And if you remember one of the first slides, I made a distinction between significant and high hazard dams. And significant hazard dams, we allow up to 1 to 6 PAR. And these would technically be people who could face high levels of danger if they did not evacuate. And studies have shown if you have 6 people who face dangerous levels of flooding, you could expect one of those would likely perish. You know, some might evacuate to higher floors in a building or whatnot. But anyway, that's where the, so with that, up to 6 people could be, you know, expected to face dangerous levels of flooding, and then 1 loss of life would be expected. So high hazard means 1 loss of life is expected.
Scott, you have about 4 minutes left.
Thanks. So how do we define the hazard? And there's hazards to people, unprotected person, to buildings or homes, and to the traveling public. And we use these charts that are in the back of the guidance document and available in a spreadsheet on our website. This is for unprotected person. And basically what defines a hazard is if you have a difference in the non-breach and breach condition that changes from a low danger level of flooding to a high danger level of flooding. That defines a hazardous condition to those people. Similarly, we have the same similar charts for the traveling public. This is where would be modeled at roadways. That would be considered a hazard. And finally, for buildings, there are 2 different spreadsheets. One for houses built on solid foundation. And as you can imagine, that criteria is, or the threshold for what is dangerous to mobile homes is much less, but we also have that chart. So in the document, we lay out 3 levels of analysis. The first one is a screening level analysis that kind of clarifies what Bruce might have meant by may require analysis. The second is a simplified breach analysis, which encompasses the small ponds. And finally, which is not for today, is a standard breach analysis, which is an incremental flood analysis. And so this screening level analysis, we allow for dams up to 20 feet tall. And this is appropriate when it seems readily apparent that no hazard exists downstream, and thus the dam hazard level is estimated to be low. An example of this would be you have an 8-foot tall dam that discharges to a steep stream valley where homes are 20 feet above the stream channel. Or let's say your pond discharges directly to the Potomac River. It's apparent that this is a low hazard. So we can write those off without. The engineer still needs to sign the statement and, you know, lay out what they took into consideration for this analysis, but that's the basis of it. And for the other 2 analyses, a simplified breach analysis and a standard breach analysis, there's a simple recipe, and that recipe goes something like this. Determine the breach and non-breach flows, route those at all relevant locations, analyze the change in downstream impacts between breach and non-breach, as I showed previously, to a point where the difference between those flood waves is less than a foot, or it's apparent that the hazard has terminated. And finally, determine the hazard classification based on those charts. So the simplified breach analysis is applicable to dams up to 20 feet. This has changed since Bruce's guidance to be more in line with dams that we can exempt up to 20 feet tall. The previous guidance was up to 15 feet, so we kind of closed this gap there. Drainage area less than a square mile, storage area less than 20 acre feet, and it cannot be a dam in series. What this, the basis of this is a simple brim up analysis. So you can imagine we fill the pond to the top and it would catastrophically fail. This is what brim up means. There is a simple method for doing this using a spreadsheet. All you need is a stage discharge table, which your engineer should have. If they don't have it, maybe they shouldn't be designing ponds. You determine a brimful queue using this spreadsheet, and you model at all these downstream locations, houses, roadways, places where unprotected persons could be expected. Here's an example of the spreadsheet. Again, this is on our website at the link that Karen has provided in the chat. You fill in the height of the dam, and this is where it differs from Pond Code 378. This actually accounts for the storage volume behind the dam. So you can imagine Pond Code 378 makes no distinction between a 1 acre-foot storage volume with an 8-foot dam and 100 acre-feet storage volume behind an 8-foot dam. You can imagine there's a significant difference if either of those breached. We also have a section on conducting a simplified 2D analysis. I encourage this whenever you can because this actually considers storage area downstream of the dam. An example of which you can see a pond breaching in these animated photographs, and because the volume behind the culvert downstream is greater than what's in the pond, it doesn't ever overtop the roadway, whereas if you had done a more simple analysis, 1D analysis, we would have shown a hazard to this high volume roadway. And finally, standard breach analysis, similar to previous guidance, any dam greater than 20 feet tall, greater than 20 acre feet in storage, greater than a square mile, must conduct this. Or your simplified analysis shows that you've impacted a house. Then we need another level of scrutiny. What this consists of is 5 events: sunny day, 100-year flood event, a flood event that fills the dam up to the top, and then a probable maximum flood analysis and a half probable maximum flood analysis. You run a model that has no breach condition and a breach condition for all those events, like the graphic here, and you analyze it at all critical locations like we said previously. So this is a much more in-depth analysis, which is most likely outside of the realm of what we're talking about in what's in your pond presentations. And before I finish, just a few common mistakes. Here's a dam, and something we commonly see is a single cross section to analyze the hazard of this dam breaking to all the downstream houses and roadways. As can be expected, how can we analyze depth and velocity of flow downstream at these roads and houses if we have a single cross section at this upstream location? And the answer is you can't. What we would like to see is sufficient cross sections to be able to model or a 2D analysis to be able to determine the depth and velocity of flow at all these critical locations. Only then can we be confident that we've assessed the hazard due to dam breach at this dam. And finally, I didn't provide a slide on this, but commonly we were provided with a graph that shows the width of the stream valley and the length of the stream valley to determine how long they need to conduct a dam breach analysis. This is not acceptable, but I believe I've used up all my time, so at this point we can go to questions.
So we have 5 minutes for questions.